The morning of July 10th, 1943, began like any other Mediterranean summer, sunrise hot, heavy and shimmering with dust. But to the German observers positioned near the Sicilian coastline, something unusual rolled out of the surf. It was a shape they had seen only in grainy reconnaissance photos. A boxy silhouette moving faster than expected, clattering forward with a strange confidence, as if the battlefield belonged to it. It was the American M4 Sherman. At first, German officers didn't understand what they were seeing. The tank's armor was thinner than a Panzer IV. Its main gun lacked the piercing power of the Tiger. And yet somehow, these inferior machines kept appearing, and surviving, and advancing. They crossed rough ground without stalling. They slogged up steep sun-struck hills without overheating. And most strangely, when one was knocked out, two more seemed to arrive before nightfall. Within days, German recovery crews had seized several damaged Shermans and transported them back to the Kummersdorf proving grounds. The engineers were eager, almost excited. They believed they were about to expose the weaknesses of American industrial design: cheap steel, crude welding, rushed production. But when they opened the first Sherman's hull, the room fell silent. What they found was not sloppy construction, but intentional simplicity. Every component looked replaceable. Every system looked standardized. And one unexpected feature hidden deep inside the tank left them genuinely confused. Why would the Americans spend resources on something like this? What the Germans discovered over the following weeks didn't just challenge their engineering assumptions. It revealed why the Sherman could appear everywhere at once, why it kept moving when others broke down, and why its real power had nothing to do with armor, guns, or thickness of steel. It was something deeper, something they had never designed for, something they could never copy. The first Sherman arrived at Kummersdorf on a flatbed railcar, its tracks still caked with Sicilian sand. German officers clustered around it like surgeons examining an unfamiliar patient. They expected poor craftsmanship. They expected shortcuts. They expected to confirm what propaganda had told them for years, that American industry focused on quantity, not quality. But the moment the engineers opened the inspection panels, those expectations began to crumble. Inside the hull, the Germans discovered a layout that looked almost organized. Wiring runs were neatly routed. Components were positioned for easy access. Even the bolts and brackets followed predictable patterns. This was not the chaotic interior of a machine rushed through assembly. It was something fundamentally different. A tank designed to be assembled, disassembled, repaired and reassembled in a fraction of the time German armor required. One engineer muttered, almost annoyed, that even the welding is good, uniform, fast, efficient. Another noted that most of the parts appeared modular, not custom fit. That was almost unthinkable in German tank design, where each vehicle relied heavily on specialized machining. Field reports from North Africa had hinted that the Americans fought a different kind of tank war. British officers in Tunisia wrote that Shermans arrive faster than we can move them. German units observed that when they destroyed a platoon of Shermans, more appeared within days. They assumed the Americans were simply producing too many. But here inside the steel carcass of the captured tank, the engineers realized quantity wasn't the whole story. The Sherman was designed for mass. Every hinge panel and connection point had been built with replication in mind. The tank wasn't just a weapon, it was a product. And that difference would prove more dangerous than any armor layout or gun caliber. Yet the engineers still kept asking the same question. Why did it survive so many mechanical hardships? Why did it keep running when German tanks, known for precision, often broke down? The answer was sitting right in front of them, hidden in the Sherman's bones, but they didn't understand it yet. When the engineers finally ran the captured Sherman through its first mobility tests, they assumed it would fail quickly. German tanks were notorious for requiring meticulous preparation before even starting an engine. A Tiger demanded careful warming, precise lubrication checks, and constant attention to its transmission. A Panther needed skilled mechanics just to avoid tearing its final drives apart. So when the Sherman was fueled, started, and driven off with barely more than a shrug from its crew, the engineers were baffled. The tank crawled through mud pits, climbed steep earthen berms, and powered across uneven terrain. It rattled loud almost crudely, but it kept moving. Even after hours of cross-country punishment, the engine temperature refused to spike. The suspension absorbed impacts that would have crippled a Panther's wheels. And when the tank finally returned to the test stand, the crew reported nothing more than minor vibrations. One German officer snapped, "This can't be right. It is too simple." But that simplicity was the point. The Sherman's radial engines, adapted from aircraft power plants, carried enormous reliability margins. The drivetrain tolerated abuse that would destroy a German gearbox. Its suspension, designed originally for interwar prototypes, might have looked old-fashioned, but it was nearly unkillable. Across Kummersdorf, memos began to circulate. One described the Sherman as mechanisch zuverlässig bis zum Übermaß, mechanically reliable to an extreme. Engineers tried pushing the tank harder deliberately, skipping maintenance steps, running it with worn fluids, stressing the suspension with sudden turns. The Sherman stubbornly refused to break. This reliability sparked a completely unexpected debate inside the Wehrmacht. Should they try to build something similar? But when designers began examining the drivetrain and suspension for potential reproduction, they ran straight into a wall. Germany simply did not have the industrial flexibility or spare manufacturing capacity to mass-produce such standardized components. Their factories were built for precision, not volume. Their supply chains were fragmented. Their labor force was strained and shrinking. The Sherman, they realized, could run almost anywhere because it was designed to be built everywhere. Still, one part of the tank bothered the engineers more than anything else. A system inside the hull that made no sense to them, at first something they considered excessive, even wasteful. And yet, it would become one of the Sherman's biggest survival advantages. The next revelation came not from mobility tests, but from the dismantling process. German engineers lowered themselves into the Sherman's hull, expecting a maze of cramped systems. Instead, they found order-open spaces, predictable, component placement and removable sections that could be unbolted in minutes. They were stunned. A Panther's interior demanded expert mechanics. Replacing a transmission could take days. A Tiger's engine required a workshop, a crane, and often an entire support unit. But here, in the captured Sherman transmissions, sat on rails for quick removal. Electrical components were standardized. Even armor plates were welded with a consistency that allowed subassemblies to be replaced without fitting or machining. To German engineersmen who believed tanks should be precision-built masterpieces, this was almost offensive. One wrote in a report that the Sherman's construction was industriell, handwerklich, industrial, instead of artisanal. He meant it as criticism. He didn't realize he was describing the tank's greatest strategic advantage. American factories treated tanks like automobiles. They used assembly lines. They applied interchangeable parts. They designed for mass repair, not bespoke craftsmanship. The Sherman could be rebuilt in the field using pre-made kits the size of small crates. Damaged armor sections could be cut away and replaced without factory-level tools. In contrast, a damaged Panther sometimes had to be abandoned not because it was destroyed, but because repairing it was too difficult on the battlefield. German tank crews began filing frustrated complaints. They admired their machines' firepower and armor, but their availability rate kept dropping. The Panther, a remarkable design on paper, suffered from fragile final drives. The Tiger required 10 liters of oil simply to start its engine. And once these tanks broke down, they stayed broken for a long time. Meanwhile, the Americans rolled fresh Shermans off transport ships by the hundreds, repaired others overnight, and returned them to battle within a day. The Germans could match the Sherman in combat performance. They could not match the American philosophy behind it. And yet, while engineers respected the Sherman's mechanical practicality, there was one feature inside the hull that left them speechless, something they had never installed in their own tanks. A system that made the engineers ask, are the Americans trying to protect the crew more than the machine? When engineers inspected the interior of the Sherman's engine compartment, they paused. Then they stared. Then they began muttering among themselves. Running along the inner walls was a CO2 fire suppression system, a network of tubes designed to flood the compartment the moment a fire broke out. It activated automatically without a crew member pulling a lever. To the Germans, this was luxurious, wasteful, unnecessary, even strange. One report from Kummersdorf stated bluntly, "Dies ist ein amerikanischer Luxus, den wir nicht haben." This is an American luxury we do not have. But this luxury wasn't about comfort. It was about survival. Combined with the Sherman's wet ammunition racks introduced after the Plaas, fighting in 1942 had revealed vulnerability to fire. American engineers had solved one of the tank's early flaws. Ammunition stored in water-jacketed racks dramatically reduced the chance of internal explosions. Crews who once feared the Sherman's reputation for burning now discovered a tank that protected them instinctively. This shocked the German evaluators. Their design philosophy centered on protecting the tank, its gun, its armor, its performance, and not necessarily the men inside. The Tiger and Panther had no automatic fire suppression, no water-cooled ammunition storage, and few internal systems dedicated to crew survival beyond basic ergonomics. The Americans, however, built an interior environment that treated soldiers like valuable assets, not expendable operators. For the German engineers, this discovery was awkward. It implied that American designers were planning not just for battlefield performance, but for long-term manpower preservation. The Sherman cared about keeping its crew alive, because a trained crew was far harder to replace than a tank rolling off an American assembly line. As one officer noted in a captured memo from Italy, "The Americans protect the crew because they expect them to fight again tomorrow. We protect the tank because we expect to build another." Yet even this revelation didn't explain how the Sherman could dominate entire campaigns. Fire suppression didn't win wars. Wet ammo racks didn't advance across continents. The engineers knew something was still missing, a key factor the Americans had built into the Sherman from the beginning. And when they finally discovered it, everything about the war suddenly made sense. German engineers had finally understood the Sherman's mechanics, its simplicity, its reliability, and its crew protecting systems. But none of that explained the biggest mystery of all. How were the Americans replacing Shermans faster than Germany could destroy them? The answer revealed itself not in the tank's hull, but in the paperwork. Stacks of captured Allied documents, shipping manifests, replacement schedules, fuel and ammunition, flowcharts, maintenance interval, logs painted. A picture so overwhelming that some German officers initially thought the numbers were misprints. American factories were producing not just tanks, but everything a tank needed to survive. Fuel, oil, tracks, transmissions, engines, ammunition, even complete replacement hulls. And all of it moved through a supply network designed with the same principles as the tank itself: standardized, predictable, modular. One German analyst wrote that by late 1944, some American units were receiving Sherman's schneller als sie ausgeladen werden können, faster than they could be offloaded. The sheer volume stunned the engineers. Germany built tanks slowly, carefully, with exacting craftsmanship. A Panther required thousands of specialized components. A Tiger's drivetrain consumed so many resources that some factories could produce only a few a month. But the United States had optimized every link in the chain. Factories made interchangeable parts. Trucks delivered them through redundant supply routes. Frontline crews received pre-assembled repair kits. Battalions swapped out engines like changing a tire. Shermans were not just durable, they were designed to keep moving through an unstoppable industrial bloodstream. And this is when the German engineers realized the ultimate truth. They could copy the Sherman's shape. They could copy its armor layout. They could even copy its mechanical systems. But they could never copy the thing that made it truly powerful, the supply machine behind it. Germany didn't have the oil, didn't have the steel, didn't have the labor force, didn't have the manufacturing infrastructure, didn't have the shipping capacity. The Sherman was not built to win duels. It was built to win campaigns. But the revelations weren't over, because, soon after, German tank crews themselves began making an unusual request that embarrassed their own engineers even more. They wanted to use captured Shermans. It began quietly, just a few reports from field commanders in Italy and Normandy. Then more from the Eastern Front. German units short on working vehicles began requesting permission to operate captured Shermans. At first, High Command dismissed the requests. Why would elite Panther and Tiger crews want an American tank that German propaganda mocked as inferior? But those who had actually driven the Sherman knew the truth. They liked it. A Panther commander near Anzio reported that the Sherman's mobility in soft coastal terrain Übertrift unsere Erwartungen exceeded our expectations. Its engine started reliably. Its transmission didn't shear teeth under stress. Its tracks handled mud without shredding themselves. A Tiger crew near Warsaw wrote that while the Sherman lacked firepower, it fährt wie ein Traktor drives like a Fahr, tractor meaning it simply worked. And as German logistics collapsed in late 1944, fuel shortages worsened, spare parts vanished, and many frontline tanks were abandoned, not due to enemy fire, but because they couldn't move. The Sherman, however, was forgiving. It ran on lower octane fuel. It tolerated long gaps between maintenance cycles. Its components rarely failed catastrophically. And when something did break, it could often be fixed with improvised tools. Some German crews even swapped out destroyed vehicles for Shermans during battle, choosing reliability over prestige. It happened often enough that the Wehrmacht issued limited operating notes and identification sheets for American vehicles, explaining how to start the engine, adjust the controls, and avoid friendly fire confusion. But the most telling moment came when an officer writing from northern France delivered a line that no German engineer wanted to read. Wenn wir diese Panzer in unserer eigenen Armee hätten, würde der Krieg anders aussehen. If we had these tanks in our own army, the war would look different. The engineers at Kummersdorf understood exactly what he meant. By then they had spent months dissecting the Sherman. They had studied its hull, its engine, its suspension. They had mocked its simplicity, questioned its design choices, and dismissed its lack of sophistication. But now they saw soldiers, experienced crews preferring the machine they once underestimated. And as the war drew to a close, a final layer of truth emerged from post-war analysis. A truth that made the engineers admit something they had resisted for years. They had never been able to build a tank like the Sherman, not because they lacked skill, but because they followed the wrong philosophy. After the war, captured German engineers and officers participated in Allied interviews and technical studies. They were candid, sometimes painfully so. The Sherman's secret wasn't just its hull, gun, or armor, it was the entire philosophy behind it. German heavy tanks had been engineering marvels. The Tiger I boasted thick armor and a cannon that could pierce almost any Allied tank at long range. The Panther combined sloped armor with powerful firepower. On paper, these machines were superior, but post-war analysis revealed a glaring weakness. Their genius came at the cost of practicality. Each Panther or Tiger was a fragile masterpiece. It required constant maintenance, specialized factories, skilled crews, and a near-perfect supply chain, all of which Germany could not sustain under wartime conditions. The Sherman, by contrast, was designed for the opposite approach. Its creators embraced simplicity, mass production, and logistical foresight. Engines could be swapped in a day, tracks could be repaired in hours, armor could be replaced in the field, and every part from the main gun to the smallest bolt was made to exacting standards, but within the framework of speed and interchangeability. American engineers, many drawn from automotive backgrounds, understood one fundamental truth. A tank need not be perfect. It need only arrive function and be repaired faster than the enemy could destroy it. The Germans, meticulous as they were, could never reproduce that balance. They built machines that were technically superior but strategically impotent. Once the war ended, German heavy tanks vanished from battlefields within weeks. The Sherman, in contrast, survived for decades, serving in armies worldwide, continually upgraded and reliably, testament to the genius of industrial design over raw technical brilliance. And in the end, all of it traces back to that first captured Sherman in July of 1943. The tank Germany tried to copy, dissect, and emulate but could never truly understand. Its real secret wasn't in the steel. It wasn't in the gun. It wasn't even in the armor. It was in the idea that a tank could be a weapon of logistics, a product of a system designed to sustain war, not just win battles. The Sherman wasn't just a tank. It was a declaration. Victory belongs to those who can build, repair, and supply faster than the enemy. And Germany, for all its engineering brilliance, could not match that.